Okay, so this is another topic of another class or another lecture of matrix. No. Okay, so last class we have discussed about the types of matrices. Again, we are going to discuss some other types of matrices. The first one is null or zero matrix. A matrix is said to be null matrix or zero matrix where all the elements of that matrix should equal to zero. A matrix whose all elements are zero. Matrix whose all elements are zero, known as null matrix. Matrix whose all elements are zero, known as null matrix. For example, so these are the examples of these are the types of zero matrix or null matrix we can say. Now, what are equal matrices? Two matrices are said to be equal if they have same order and the corresponding elements are same. We can say two matrices are said to be equal if they have equal number of if they have equal order of equal order and their corresponding elements are same. So two matrices are said to be equal if they are of equal order and their corresponding elements are same. For example, if I say there are two matrices A and B, look at the matrix A. A is a matrix of order 1 into 4. There is a one row and four column, and B is another matrix. of 1 into 4 order orders where the rows of this matrix is 1 and the columns are 4 have elements A, B, C, D, then they are equal, then they are equal, then these two matrices are equal matrix if A is equal to 1, B is equal to 2, C is equal to 3, and D equal to 4. So these two matrices are said to be equal corresponding to their order and their element. Now, some algebra of matrices. Addition of matrices is possible. Two matrix A and B, two matrix A and B no, in this way, we can write, we can add two matrix A and B with their corresponding elements and we get a new matrix C after addition of them, after adding them. So addition of matrices is possible addition of matrices is possible and after adding their elements, we get a new matrix C, which is equal to A plus B if A is a matrix and B is another matrix. Same order, where A and B are two matrices of same order, where A and B are two matrices of same order. For an example, yeah, for an example, if A is equal to matrix of elements 1, 2, 2, 3, and B is another matrix of elements 3, 4, 0, 1, then after adding them, we get a new matrix C. C is equal to A plus B, whose elements are 1 plus 3, 2 plus 0, 2 plus 4, 3 plus 1. It is equal to 4, 2, 6, 4. Similarly, we can subtract matrix. So subtraction of matrices is also possible. Now, the second one is subtraction of matrices. It is also possible. We can subtract two matrices elements. It is also possible. It is also possible. We can subtract the elements of two matrices. We can subtract the elements of two matrices. Two or more matrices. For example, and after subtracting, we get a new matrix. And after subtracting, we get a new matrix. So if I say C is equal to A minus B, where C is a new matrix, which we get after subtracting the elements of matrix A and B. Matrix A and B. Here, A and B are matrix of same order, where A and B are same order matrix. For an example, if A is a matrix of order of elements 1, 2, 2, 3, and B is another matrix whose elements are 0, 1, 2, 1. And after subtracting them, we get a new matrix C whose elements are 1 minus 0, 2 minus 2, 2 minus 1, 3 minus 1. So after subtracting it, we get a new matrix whose elements are 1, 0, 1, 2. Now, after adding these two things, after knowing these two things, addition and subtraction of matrices, we get some result. So what are the result? These are the results. Where addition and subtraction of matrices we can say that matrix addition is commutative. We can say that matrix addition is always commutative. But matrix subtraction or the difference of matrices is always not commutative. But subtraction of matrices is always not commutative. It, Sometime it may be commutative, sometime it may not be commutative. It depends on the elements of the given matrices. But subtraction of matrices is always not commutative. Now, that means A plus B is always equal to B plus A. That means A plus B is always equal to B plus A. But A minus B is always not equal to B minus A. Now come to the next term, that is matrix multiplication, or we can say multiplication of matrices. Multiplication of two matrices. So two matrix multiplication is only possible when the first matrix column is equal to second matrix row. Otherwise, it can't possible. two matrix multiplication two matrix multiplication is only possible when the first matrix column is equal to second matrix row. Otherwise, it can't happen. It can't possible. So if A is a matrix of order n cross P and B is another matrix, B is another matrix of order P cross M, then the matrix multiplication will happen and we get a new matrix and we get a new matrix of order. We get a new matrix C of order n cross M. Look at an example of this. A is a matrix whose elements are 1, 2, 3, 3, 2, 1 of order 2 cross 3. Here the number of rows is 2 and the number of columns are 3. So it is a matrix of order. It is a matrix of order 2 cross 3 and B is another matrix whose elements are 1, 2, 3, 3, 1, 2. It is B is another matrix of elements 1, 3, 2, 1, 3, 2, whose order is 3 cross 2. There are 3 row and 2 columns. So look at the two matrices A and B. Here in the first matrix A, the number of columns is equal to 3, and in the second matrix B, the number of row equal to 3. So both matrices, in this both matrices A and B, the first matrix column is equal to second matrix row. So here the matrix multiplication is possible and we get a new matrix whose C, whose order is of 2 cross 2. So we get a new matrix C of A into B. So what is C? Now we are going to multiply the matrices. We are going to multiply the first matrix column with the second matrix row. Sorry, the first matrix row with the second matrix column. So the first matrix row with the second matrix column. So 1 into 1, then plus 2 into 2, then plus 3 into 3. Then again 3 into 1 plus 2 into 2 plus 1 into 3. Again it is 1 into 3 plus 2 into 1, 3 into 2. Three into 3. The next one is 3 into 3 plus 2 into 1 and plus 1 into 2. After calculating it, we get a new matrix whose elements are 1 plus 4 plus 9. That means 14. Again, 3 plus 4 plus 3. So 10. Then 3 plus 2 plus 6. So 11. And 9 plus 2 plus 2. So that is equal to 13. So this is a new matrix. We get a new matrix. Just wait. We get a new matrix C whose order is 2 cross 2. Now, again, the multiplication of matrices has some order. It is always not commutative. Matrix multiplication is always not commutative. Matrix multiplication is always not commutative. That means A cross B is not equal to B cross A always, but when one matrix is identity matrix is of identity matrix, we have already discussed what is identity matrix. A matrix which has only a matrix which has only diagonal elements, and the diagonal elements should be equal to 0, and all other elements should be equal to, identity matrix are those matrix which has only diagonal elements, and all diagonal elements should be equal to 1, and all other elements except the diagonal elements are equal to 0. So one matrix is of identity matrix, then Matrix multiplication is commutative. Then matrix multiplication will be commutative. Is commutative. That means A into I is equal to I into A. So this was the algebra of matrices where we have learned about addition of matrices, about subtraction of matrices, and multiplication of matrices. And one more thing, division of matrices is not possible. We can find inverse of matrices by dividing the matrices by dividing adjoint matrix after dividing adjoint matrix by determinant of that matrix. So the matrix division is not possible. Thank you.